Welcome, everyone. In this video, we're going to be talking about experiments, what experiments are, and how the design of experimental research can apply to what we're going to learn in research methods throughout the rest of this course. To start, we're going to talk about what is an experiment. An experiment is a research design where investigators manipulate one or more independent variables and observe the effect on a dependent variable. This is typically done in like a laboratory setting. Our common knowledge of and understanding of experiments comes from the physical sciences, where people would run experiments in a laboratory using either chemicals or biological experiments, but they also can be done with human participants as well. The idea is that there's some treatment or intervention that's being introduced that is intended to impact the dependent variable of those in the experiment, whether those are humans or substances or materials, to be able to determine if the introduction of that intervention is something that would potentially cause a change or a reaction. This is typically beneficial because it can control for confounding factors. What that means is, when you have two petri dishes in the same laboratory to the same conditions, and you only add an intervention or treatment or a mechanism to change one of the two, all other conditions in that laboratory, the temperature, the humidity, right, the time and date, and all of those other things are controlled for because they are in the same setting, but one of them has been treated differently than the other. That allows for the control of outside factors from interference, because if you did the same thing to petri dishes and one was left, in a different room near a window with a cracked window opening, as opposed to something that was in a dark, musty laboratory that had no windows and no exposed air, you might get different reactions, and it may not be the result of the exposure that you introduced, but it could be any of the other conditions. And so laboratory environments allow for control of these confounding factors by keeping everyone in similar settings for the duration of the experiment and only really changing the thing that is being introduced or the intervention that is designed to potentially have a change. Uh, This is also used to establish causal relationships by systematically testing hypotheses. What that means is we have a when we have a hypothesis, we have a belief that there is some type of a relationship that will occur as a result of introducing whatever that intervention is. And so by testing the introduction of that intervention to a group, right, we can determine whether or not the change that we think should occur occurs. Experiments are very well suited for projects involving limited and well-defined concepts and propositions, right? They work best when we have clear relationships. We have a clear ability to control what the intervention is. We have a clear ability to sort of control the confounding factors and introduce something, whether that's if in a drug trial, that might be a new medication. In a laboratory experiment, that might be exposure to information. In a laboratory, that might be addition of a chemical or additional heat. So in those scenarios, right, there's potentially clear relationships, there's clear criteria, and they work really well for those type of situations, right? They don't work as well for broad and complex social phenomena, meaning when we are looking at like, well, why do people choose to be religious or pick the religious affiliation that they have? Well, that's broad and that's complicated, and it takes place over, an entire lifespan for a person, and it may change and fluctuate. And so something like that, trying to introduce, if I have someone watch or read a passage of a Bible in a laboratory and see if that intervention causes people to become religious. But that's not really what experiments are well designed for, because social phenomena like being religious is a very complicated thing. But as we said before, right, they are well designed for a number of things, including the ability to do hypothesis testing. This is looking at testing causal claims. We can manipulate the intervention, what the treatment group that is part of the experiment does and does not receive can be controlled in an experiment. Right? We are the ones that get to apply the chemical or apply the heat to the petri dish, so to speak. And so we are able to then test our hypotheses, what we think is going to happen, and does what we think going to happen actually occur, right? They are better suited for explanatory research. What that means is we do experiments because we want to introduce an intervention and see if that results in some type of impact, right? Does the intervention that we introduced cause something to change, right? That is what we call explanatory research, because if something does change, we often conclude that, well, that change is a result of us introducing that intervention. Descriptive research that looks at like patterns and what is happening, trends and what is occurring, right? Those are not really what experiments are for. If we want to know who is being infected with COVID-19, who's it transmitted to, and which groups are, most adversely impacted in terms of being hospitalized or dying, right? Experiments don't really do that type of thing and may not be appropriate for that type of thing. That is more descriptive research that's going to look at sort of large scale social patterns and describe what's going on. They also tend to work well for small group interaction, especially in social science where we are studying people and human behavior. They are ideal for, whether these are randomized control trials or focus groups, small group settings. Experiments work well in this scenario versus, trying to pilot test an initiative across all 40,000 Cal State Long Beach State students, right? That's not kind of the setting that is ideal for an experiment. So what makes something an experiment as opposed to other types of research design? Well, we're going to talk about different research designs, but it's important to understand experiments first because experiments tend to be sort of a foundational element that we all tend to understand just because we learn very early in terms of like science classes growing up, like how to do an experiment, right? And then most other types of research designs really tinker with the structure of an experiment by adding or changing or removing different elements of it. Right, but there are a couple of key features of which there are three main ones in terms of what makes something an experiment. The first being manipulation that occurs. The researcher is deliberately introducing a change. There is some intervention that we provide, whether that's providing information, we're exposing to a chemical, we are providing an incentive, we are doing something that is independent of what is happening with the group being experimented on that we think is going to cause a change, a reaction, some different outcome as a result. Observation, we obviously want to measure what is happening, the outcome of interest. We might be interested in whether somebody's COVID-19 symptoms are better or worse. We might want to know if somebody is more or less prejudiced. We might want to know if somebody would change their opinion on a policy or if a person's success in a social outcome is better off as a result of some type of services being delivered. Any of those things can be an outcome, and the goal is to measure and see if there's a change in the outcome. Now, lastly, there's a control element. We try to minimize external influences. This is that co-founding factors, right? We want to control everything in a similar environment so that we know that nothing else can potentially be the result of any changes that we experience other than the manipulation that occurs. We introduced something, everything else stayed the same. And if something changes, we can conclude that it's as the result of, or there's a cause and effect relationship between that manipulation and whatever outcome that we have observed. Major components, as we've stated here, right? We tend to have both independent and dependent variables, independent being some manipulation that occurs, and the dependent variable being whatever that resulting effect is. So we think about stimulus and effect. In short, right, I've introduced a stimulus. What is the effect of that stimulus being introduced on whatever's being experimented on? We often then have pre-tests and post-tests, meaning that we are measuring change both before the stimulus, or what we would call a pre-test, and after what we would call a post-test. And then we also typically have both experimental and control groups. The group of participants or the Petri dish or whatever it is that receives the stimulus is what we would call the experimental group. They're the one being experimented on. The control group is the one where they are very similar in all other aspects to the experimental group, but they are not receiving the manipulation. They are not receiving any type of a stimulus. We use that as a control. If it's the other Petri dish that is in all other ways exactly the same as the one I'm experimenting on, by adding a chemical and watching what happens, if there is a change and nothing occurs to the control Petri dish, I can assume that it's the manipulation that has the cause that I observe. If the other Petri dish, if it was some type of external factor, we would see change in both of those Petri dishes. And therefore, right, the control tells us, well, it wasn't my manipulation that caused the change because something happened in both of these, and that control didn't receive any type of manipulation or intervention. Types of experiments. I'm going to give a few different examples here, some of these from the textbooks, others from just sort of real life research, so that you can get a kind of a range of different experiments that we see particularly in the non physical sciences domain, right? So social experiments. This is talked about in the book, looking at prejudice and whether we believe that individuals are prejudiced against Muslims, Muslim persons, Muslim culture. The one group can be manipulated by, and I want to be clear, when we say manipulated, we mean that we're intervening and providing information or changing their circumstances in some way, not necessarily manipulation in always a negative sense, but manipulation meaning, right, something is being introduced or changed as a result of we, the researcher, introducing it. And so in this scenario, the book talks about the idea that, right, if persons are prejudiced against Muslim persons, that potentially introducing a book or an article about historical contributions of Muslims to society, or having them watch a snippet or a full-length documentary about Muslim contributions to civilization, that can be the manipulation, the intervention that we provide to see if whether exposure to that information might result in people having less prejudiced opinions about Muslims after being exposed to that information than they did before they started. Another example, policy experiments on fiscal knowledge and spending preferences. This is something that I did for my dissertation research, but the idea was that I undertook a research experiment to determine whether or not individuals who have opinions about what the government should spend the federal budget on really and truly understood how much we actually spend currently in the federal budget on different things. And so I looked at having those individuals identify what their preferences for spending on things like social programs, healthcare, defense, infrastructure was, without them getting any information about how much the government spends. And the experimental group or the treatment group then was given some information on the current federal budget, how much was allocated to each of those different things, and then post tested to see if there was a resulting change in their preferences for spending once they had been exposed to information about what the federal government spends. And in that research, what I found was most often the pre-test positions that people had were a lot more extreme and different from what the federal government actually spends. And whether you were conservative or whether you were liberal, after you knew what the government spent, we saw a much narrower range of preferences. And in either direction, those two groups both moved their preferred allocations closer to what the government spends. They didn't really want to shake up the current federal budget drastically. Their preferences became much more in line with what we already spend, plus or minus, small deviations one way or another, because they were not as familiar from the outset at what the actual spending levels were. Clinical experiments, these are things like drug trials. Obviously, during the pandemic period, there's a lot of different efforts to test new medication. Something that would be an experiment in this domain would be a double-blind randomized control trial, where you get a number of patients that have COVID-19 symptoms. Half of them are randomly chosen to receive a new antiviral medication, where the other half receive a placebo, something like a sugar pill or something that doesn't have any other medication. The doctors and researchers will track the severity of their symptoms, their recovery, and then use that to evaluate how quickly and how much those individuals improved. And then we would be able to determine whether the group that received that antiviral medication got better either faster or more overall than the group that received the placebo, to conclude that that intervention, that manipulation, which is the antiviral drug, had an impact on improving that group faster or more than the control group. Some other examples, something like a laboratory experiment we've talked about, the traditional idea that, we might heat a metal up to see how the conductivity changes with temperature, ensuring that the external conditions, humidity, pressure, those type of things remain constant. We might also have another controlled metal that is, we're testing the conductivity on another piece of metal that is not having heat applied to it in the same environment, in the same room, in the same laboratory, to determine if there's a difference as a result of introducing heat to one of the two. The human experiment in social science, right? We may think about like psychological research. We can see experiments in psychology where we might randomly assign half of a class of students or half of a group of people to receive a mindfulness intervention, a program on mindfulness, and the control group then does not receive anything. And we look to see if stress levels are different as a result in those two groups because the manipulation, in this case, the mindfulness programming, should help the treatment group have less stress levels than the control group that didn't receive the same intervention. And that would help us determine whether or not that mindfulness programming is successful at reducing stress levels or not. Lastly, there's an example here on this is more of a policy experiment. And so in this class, as we're thinking about program evaluation, large scale evaluations of government services and programmings, it's very often the case it's difficult to do experiments of this size. But one of the optional evaluation articles you can choose to read, which is really interesting, is on a program in Mexico called Progresa, which was a social welfare program designed to give money to households, both financial aid and health services support. And what they did was they randomly selected towns within Mexico. Some of them received the intervention, and others had to wait to start receiving the same services. And they wanted to compare whether those towns, the people who received the financial health services in those towns, saw improvement in health outcomes, nutritional outcomes, and educational attendance as compared to the other communities that were not yet receiving that social impact or social welfare program. And so it's an interesting article. Obviously, there's political pressures and all kinds of other things that result in them having to abandon it early. But what they started to observe was that the communities where they did introduce this new progressive program were showing improvements across all the participants that they weren't seeing in towns nearby in similar circumstances that were not yet scheduled to receive those benefits, to give the inclination that that program and those services had a positive impact. It was a large scale sort of national randomized evaluation, which rarely happens, but in this case was very critical to understanding the effectiveness of this type of a program. So the classical experimental design has a number of different components. And we've talked about these already, but this sort of gives you a visual breakdown of what's going on here. Right. The first is that we have a group of people, right? That group of people that is reflected here by this initial purple oval, if you want to call it. We start with random assignment, right? Half of the people are randomly placed down one trajectory, whereas the other half are put down a different trajectory, right? We have a control group, and so half of everyone that starts out is going to not receive the intervention or the manipulation. The other half is going to be the treatment group, also known as the experimental group. These can be used interchangeably, but this is the group that's going to receive some intervention. Sometimes we can not to complicate things, but in control groups at times, right? We don't always want the group to experience nothing. So sometimes we will put like a false intervention in between so that they don't feel like they are potentially clearly the ones not receiving anything, right? That is why patients receive placebo drugs because we don't want them to think and report their symptoms as not getting better because they didn't receive any type of medication. We want to give them a medication that we know is fake so that they don't act or think any differently about whether they do or do not actually end up receiving any type of medication, right? In the anti-Muslim prejudice example, we might have the control group watch a different video that has nothing to do with Muslim culture, right? And just for the purposes of them thinking that has something to do with the experiment, we might do any of those things if needed, right? But we always know that the experimental group is the one that receives the intervention and the control group is the one that does not receive. They serve as our comparison baseline. And so you can see that we're going to compare between these two different groups. Right? In a classical experiment, we have always a pretest, right? That occurs here, right? At the initial outset of the experiment, we collect data on whatever dependent variable or outcome or effect that we're interested in before anyone is manipulated or receives any type of an intervention. Right? In a classical experiment, we always have some type of intervention, whether that's a program, a stimulus, a video, a newspaper, right, a medication, whatever it is, right? There is some intervention that is applied after we initially collect data from the experimental or the treatment group. We then also always have a post-test, right? This is again measuring the outcome, the dependent variable at the end of the experiment after the intervention. So if you think about this chronologically, we are doing first one step, then the next. Right? This happens first, this happens second, and then this happens third chronologically. In this scenario, it's just two steps with the control group where we have the pretest and the post-test with nothing in between them. But that is where we can also compare at the end. And then once we have all that information, we have the ability to compare three different things, right? One of which is this comparison that occurs at pretest, where we're looking at both pretest values for the two different groups. Ideally, in this scenario, we want to see if these two groups are similar. If random assignment resulted in our two groups being generally the same across the two different groups, then whatever we see, right, the average level of prejudice across these two groups, or the average level of spending on defense that one of either two groups would be interested in, should be about the same, right? If liberal and democratic persons are equally split across both of these groups, they individually are going to have different preferences, but on average, we would think that the result of pretest preferences should be about the same, because they're just an average group of citizens and voters that should otherwise be no different, right? We then introduce the intervention, we expose them to information, and then we can do a different comparison here at post-test, where we look at the same two groups before and afterwards. If we envision that the experimental or the treatment group was impacted as a result of our intervention, we would see something like, we might see different spending preferences here for the treatment group. The average would be different than this group, right? At the post-test, because at the pre-test, we expected them to be about the same, right? But the amount of money, let's say, for example, people think we should spend 33% of the budget on defense here on average, and maybe in this scenario, they think it should be about 34.5%. That may be totally reasonable, just to have a slight difference between the two groups because they're not perfect, right? At the end, we might see something like 34% of the average amount of funding that we think this group should spend on defense is about 34%. That hasn't changed much from the initial 33% value. But here, right, we might see something like 18.4%, right? Maybe that's because we don't spend 33% on defense, and that group's opinion overall changed as a result. And so we now see both the difference between these two values, which is something we want to compare, the post-test comparison, and then we want to look at the we call within group experiment. So we want to look at the fact that the 34.5 changed to 18.4, right? And we can see this comparison highlighted here, where we're looking at the difference between the pre-test and the post-test values for the experimental group. And we believe that in this scenario, the intervention itself probably resulted in this drop from 34.5 to 18.4, exposing them to information about how much the government spends on defense resulted in a big drastic shift that we didn't experience or observe in the control group, which leads us to believe that that intervention caused that change. Later in the class, we're going to talk about this idea of the X's and O's framework. X's and O's framework is really just a simple way, a summary view, if you want to call it, of creating something like the diagram on the right, but a more simple version that looks something like what's on the left, right? So what you can see here is we have two groups, right? We consider this group 1, we consider this group 2, control group, and the treatment group, right? We have two time periods, time period 1, that would be the pretest. We have time period 2. So this is our pretest, this is our post-test. Same thing here. This is time period 2, because it happens after the exposure, right? We have assignment, right? Well, they are randomly assigned, so that happens here. If they're randomly assigned, because we do choose random assignment in an experiment, we would indicate that with an R. It's also very possible, one of the things that we'll see later is that not all things can have and allow for randomization. So we could put this as NR if these were non-randomly assigned groups. This could be non-random assignment. So when something's non-randomly assigned, it's called a quasi-experiment. We'll talk more about those. But in this example, because it is random assigned, each of the two groups is randomly assigned. There's an R indicated here, right? Then what we look at is we look at across time periods. We have a pretest, so we consider the data collection that happens here when we first collect dependent variable or outcome data. We consider that O1. That's observation point number 1, right? We then, for group number 1, have an X. X indicates that there's an intervention applied. X can be indicative of an experiment. It might be the start of a government program or services being received. If somebody comes to a homelessness or housing support program and we start delivering them services on a certain day, right, when we begin delivering those services is indicated by the X. thinking about this time period, right, chronologically. So this is earlier in time, and this is later in time. And so, right, as things move from left to right, we're talking about a chronological change in time. Right. For the time period 2, we have a post-test that would be indicated by the second dependent variable where we observe the outcome again, O1 and O2. In the second group, the control group, we also observe at the same point in time. So that's indicated by what would be O3 here. Right? There is no intervention, so we don't have an X because there is no intervention being applied to this group. But we do continue to post-test at the same time and therefore have observation number 4. So you can see what we have outlined on the right is a graphical version or representation, whereas the X's and O's framework we have on the left-hand side is a more simplified and streamlined version of communicating the same type of information. Each time we have an observation being collected simultaneously from one or multiple groups, it's indicated with an O. Whenever there's an intervention or manipulation applied, we have an X, which indicates within which group at what point does that occur. We identify whether there is random or non-random assignment between those groups, and then we have a chronological indicator of the time period transitioning from earlier in time to later in time by more or less items, observations, so to speak, on the left or the right side. Right now, obviously, in what we'll talk about in research design, this foundational core stays the same, but there are other things we can do in terms of, again, we might move from random, non-random. We might have potentially 3 groups instead of 2, right? We might add additional observations either before or after at the pretest or the post-test, right? We could potentially have different types of manipulations. Any of those things could be relevant and applicable here, but it's really the same core. We are just talking about altering and varying sort of the fundamentals of that process. So what that means is we can relax, so to speak, this experimental design for classical experiments. And we can do that a number of ways, right? I have mentioned non-random assignment, things like quasi-experiments, meaning when participants are not randomly assigned to the treatment or the control group, or if we have multiple groups, they may not. It does result in potentially the weaker claim of causal relationships. But in many scenarios, it's either unethical or logistically impractical to do random assignment. Right? We in government services cannot refuse to give people services because we want to randomly assign them to a group that does not receive services so that we can run an experiment. That's unethical. If people are eligible and need assistance, we have to help them. And so in many, many scenarios, while there are sort of a weaker causal relationship claim for quasi experiments, in many scenarios, it's the only option that we have. And so it's better to have some data, some evidence, some research in a quasi experiment than to do none at all. Right. So, for example, we might have a school implementing a new reading program. And so in one district, they are implementing this new program. The other district either doesn't choose to use that program or hasn't rolled it out yet, or we didn't withhold it from them for intentionally. We are just waiting to see, right? Maybe it's being implemented at a different time, or maybe a different district school board voted not to implement that same reading program at theirs, right? In that scenario, it's not random who ended up having to have a new reading program or not, right? But it is a quasi experiment. We mentioned variations in pre and post testing. We may have a scenario where we have a need for more pre-testing or post-testing. We might want to track changes over time as opposed to relying on a single measurement or observation point, right? For example, someone in a nutritional wellness program that's looking at controlling diabetes, right? If we're looking at their blood glucose levels, their A1C levels, those values, if we measure them one time after 2 weeks and then never collect any more data, that might look like they're doing well. It might look like they're doing poorly, right? But blood glucose levels change routinely and often as a result of a lot of things. And so one single measure may not be sufficient. So obviously we can add, we can also subtract. We might have scenarios where there's no pre-test. There may also be no post-test. You usually have one or the other, but in some scenarios, right, you might lose one. And that might be because, right, you might not be able to collect pre-test data because a program is already started. And so the people are already in the program, they're already receiving services. You can't go back on time and collect data from those individuals before the program started. So you may not have the option to pre-test even if you'd like to, right? Most no post test is a lot less common, but you may look at something that has already ended. And so you may be going back with a bunch of pre-test data that someone collected. The program is already over. There's no data collected after the fact, right? You might be looking at something like that. This is probably the least common example. Most of the time, we have the ability to come in and do an evaluation. We are looking at collecting after the fact post-test data. It's more common that we might not have the pre-test ability, but any of these, including the addition of more pre or post-test, can occur. Lack of a control group is another. Sometimes we have one group designs, meaning there's only a treatment group. There's no control group. That might be either intentional or because there is no comparable option, right? We might be looking at a government program that provides services to single mother immigrants who don't speak any English and earn below the federal poverty limit and also have a diagnosis of of HIV, right? That might be such a hard population to even get participating and enrolled in this program. And anyone that you might find that meets those criteria, you might want to provide services to get in this program. It'd be very difficult to find another control group of those people that are similar enough to compare against that you would just choose a one group design. You might also have alternative comparisons, meaning you might have multiple control groups of different types. You might also have multiple treatment groups of different types. Multiple treatments, for example, in drug trials, sometimes we give a placebo to a control group. We give one dosage of a drug to one treatment group. We have a second treatment group that receives a higher dosage of the same drug to determine not only if the drug works, but do people get better faster as a result of a higher dose, like 5 milligrams versus 2.5 milligrams. And so we have in that scenario two control groups, one treatment. We might also do something where we're doing an intervention, this reading program again in the school district. If we implement that reading program in a classroom, we might have a treatment group that is the classroom that is receiving the reading program. We might use one control group that are other similar grade level classrooms in that same school, right, that are not implementing that reading program. We might have a secondary control group that takes a random sample of all students within the broader school district or across different schools and different school districts within the same city or county, right? Because we want to see not only does it improve similar students in the similar school setting by comparing to individual classrooms in the same school, right? But that may also be one comparison we want to make. We also want to make a comparison against the average reading level of different students across the entire community. Maybe that school, if that school's already in a more affluent neighborhood or already has a historical trend of having high reading test scores, right? So comparing against that other group, right? They need to be higher than that other group to indicate that that reading program has a benefit, right? But we also may want to compare against sort of the average reading level to see if we're doing better than the rest of the community as a whole to determine whether or not we may not see much of a difference between different classrooms within the same school, but we might see a big difference when comparing against different schools that have a lot more variation in terms of student population, resources, test scores, those type of things. So the textbook talks a little bit about some of these variations. They don't go into all the different possible examples. That's going to happen in later chapters, and we're going to talk about that when we get to research design, right? But they do talk about things that are first step examples of relaxing some of the different experimental design decisions. So the one-shot case study here, where a single group is exposed to a treatment. So we have an individual, right? There is no pretest, nothing occurs here. We have an individual that we have an individual that's observed. At this point, they appear to be in shape, right? They exercised at some point in time. That's a one-shot case study where we can potentially conclude that this person is fit because of the way that they, as a result of their exercise, right? But as you can tell, it's hard to conclude with a lot of certainty that that is the case. We just see a fit person who happens to be exercising. Maybe it's their diet that causes them to be fit. They just happen to exercise. We don't always know. A little bit better version is the one group pre-test, post-test design. In this scenario, we obviously don't have a control group again, right? But we may have an overweight man that is observed at point one. That same person begins to exercise and then later is observed to be in better shape. That may be a result of the exercise, but it may be the result of other things like diet changes, or maybe they're exercising because they also enrolled in some type of counseling, nutrition, wellness program, and so that is actually secondary to something else that is causing the result. So we don't always know, but we can see, in this research design here. um, we see example number one here, example number two here. The third example they give in the book is the static group comparison, meaning in one scenario, we have a group that exercises that is observed to be fit. We compare that to a group that does not exercise that seems to be less fit. And we can conclude by comparing these two groups that the group that exercises is more fit or is not overweight, and therefore it's the exercise that resulted in that, right? It's difficult to know. We can't necessarily know that these two groups were the same to begin with because we have no way of knowing that. This group could have always have been fit here, right? And this group could have been not fit. And so maybe there was no change as a result of the exercise, right? Maybe this group was fit beforehand, and so there was a different change, right? We don't really know because we don't have the ability to observe. And so this is where, the absence of information at these points in time to compare, or the absence of a control group to compare against, it really improves our ability to conclude that there's a cause and effect relationship by having more information, being able to compare to different points in time to different groups that don't receive the same interventions. That is how we are able to strengthen the conclusions of cause and effect that we are claiming, or what we would call later in this course internal validity. Couple different points about experiments that folks should be aware of. Obviously, experiments, while they are considered the gold standard of research design, they are not perfect. And so there are certain things that we should know about experiments as well. For example, selection of subjects. Who ends up in that group? If we go back to this point in time, who ends up here in the first group that gets randomly assigned? We need to think about how people end up in this group chosen in the first place and what that means for the experiment. So, in most research that's published in the university setting, in the peer-reviewed journal world, many of these are over reliant on college students. Why that is? Well, faculty members work at colleges, colleges are readily available, or college students are readily available, so we can pay or incentivize college students to participate. College students tend to be younger, more educated, less diverse on average than the general population. So if much of what we know is from experiments that get published in the research world, but that research all is conducted on college students, those results may be applicable to college students, but they may not be applicable to an adult senior voter in Ohio, right? What causes someone to potentially be impacted by an intervention? It may only apply to college age people, right? It may not apply to everybody else. We don't know unless we have non-college people represented in the population that gets randomly assigned to our treatment and control group. So in my dissertation example, I specifically went out and recruited through a marketing firm a random sample of people from across America, different ages, different ideologies, right? It was a broad cross section. I didn't rely on college students because in studying something about the voting population, I needed the participation to look like the voting population. Right? If you get people from a different country who aren't American, or you get people who are not voters, right? Like any of those things that you might do when recruiting your subjects can result in things. So we need to be concerned about whether or not we can do things like random sampling, meaning improving the representativeness by choosing from a larger population that we want to draw conclusions about a subset of those people. Right? Things like convenience sampling, meaning relying on those who are convenient to us, like college students, may limit generalizability, or at least it may limit it to generalizing only about the convenience sample, right? So using only college students and concluding things about college students might be appropriate. Using only college students and concluding things about the entire American voting electorate may not be, right? And as we talked about random assignment, right, we want to be able to evenly distribute characteristics across two different groups. Therefore, if we randomly assign, it doesn't really help the external validity question, because that's more about who ends up in the group that gets randomly split into the two groups. But if they're randomly split as opposed to unrandomly split, we at least think that on average, we should be able to balance those two groups out by sorting everybody into one of two camps that are comparably equal from the beginning. External validity we'll talk more about, but it's this idea about whether the results of our experiment apply to real world settings, right? So there are other reasons, things like artificial lab conditions, sample bias, like only choosing college students, or something called the Hawthorne effect, where people who are being studied change their normal behavior as a result of being studied. And so any of those things could potentially have an impact on the generalizability of an experiment that we need to be concerned about. So there's also different things to improve generalizability. We might use field experiments. We actually go outside of the laboratory setting and do something on a larger scale. We might use one or multiple diverse samples, right? We might replicate across populations. So if something does conclude to be true about college students, we might try that with community members from the same town that the college is located in, right? We might then go out and get a different sample from a community that's unlike the city that the university is located in, right? So maybe we take Cal State Long Beach students to start, then we might see if the findings still apply to just a sample of Long Beach residents, right? Then we might go to Orange County, right? And then we might try to get a sample from Wisconsin and see if the results continue to hold in any one of those scenarios. Because if they were true about the college students at the outset, it could be true about another group, but we're not really sure until we replicate and find out whether or not that's the case. Matching is another thing the book talks about in terms of experiments. This is interesting, but also has some drawbacks in and of itself, right? The thing about random sampling, or sorry, random assignment means that you may have on average two equal groups, but there is going to be a margin of error within that, right? And so, if you only have, in this case, you have 8 African American men under the age of 30, right? It's very possible that random assignment might put 6 in one group and 2 in one group. And if this is your control group, right, and this is your treatment group, right, that's not an impossibility, right? Because the way random assignment works is you don't always know, because it's going to take each person on your list of participants and then shuffle them, right? And the way that a deck of cards, for example, might get shuffled, sometimes it works in your favor, sometimes it doesn't. That's the nature of randomization, right? But in this scenario, having only 2 African American men under 30 in the treatment group might be insufficient for what we want to study, right? So we may want to make sure that we have a better balance. So, in this example, they show African American women 30 to 50. You may first pick that subgroup and then randomly assign them from there, right? So that way you can say, I want to make sure half end up in one, half up in the other. And so in this scenario, we take that 14, randomly assign them, and we end up with an even balance of 7 and 7 in each group, right? So in this scenario, right, before we do the random assignment, right, we have the ability to take individuals with shared characteristics and then split them to be then randomly assigned into subgroups. That way the two groups have the same proportions, right? So they will have 8 and 8 African American, or sorry, 4 and 4 African American men under 30. They would have 6 and 6 African American men over 50, right? And so we can split the group up that way, right? It can be very useful when you have either small groups of demographic populations and you want to make sure that you get some balance because you can't afford for random assignment to balance things out the way that you would want, like in this example up here. At the same time, there are some drawbacks of that. The first being selection. You may not always know what factors are most relevant and end up leaving out important factors. Just because we think race, age, sex may matter, there may be other differences between these, like some of these African American men are college graduates and some of them are not, or some of them are conservative and some of them are liberal, right? If those are things that you don't take into account and you just split the group into two 50-50 groups, other factors like that may be imbalanced and that can influence the outcome, and that's not ideal, right? The other thing is the statistical constraints. Most, or at least many statistical tests assume randomization. So when you're doing an analysis of the data and you did not use randomization fully, you did this matching process, you may have to use specialized technique to account for the different type of biases that result, right? So unless you have a very strong and clear reason to do some of this matching, it certainly can be appropriate and you can correct for some of the potential bias with different statistical testing. It also may not necessarily be ideal if you can't figure out all of the potentially predictive factors, right? If I'm doing a political assessment, a political study on voters, I may very easily want to know if someone's a Republican or Democrat and randomly split those two groups so that I get an even split of those two, right? And then leave out splitting by race and by sex and by age, because as long as I know political ideology is balanced between two groups, like that may be appropriate. At the same time, if my group initially ends up being about half liberal, half Democrat, and I still just choose full randomization, I will get about a half liberal, half conservative treatment and experimental group and control group at the end, just by nature of randomization too, right? So you usually need to have a good justification for deploying matching, but it is an option for people to be aware of. So as we've talked about here, there's a number of different strengths and weaknesses of using experiments, right? It is great for causal inference. Experiments can help us analyze and look at cause and effect relationships by manipulating variables and controlling the conditions of the experiment. We have this level of control to isolate just the impact of whatever manipulation is introduced and nothing else. They are repeatable, especially if they're under like laboratory environment settings where we are very controlled. Someone can easily do the same experiment another time in a different laboratory with different people at a different time and the same intervention. Right? There's a lot of internal validity, right? Basically, what that means is we have strong confidence in the cause and effect relationship that we find as a result or conclude exists, right? And then there's also, lots of interesting applications, things like randomized controlled trials, policy, medicine, places where, especially where things are very complicated to study, unlike the physical sciences, they can really help be a very strong way of testing these type of things. Right? At the same time, there are generalizability or external validity concerns, right? Artificial settings like laboratories may not feel like real world conditions. That can make it harder to apply the findings broadly. There can be ethical constraints. We'll talk about these here, but obviously, like we can't withhold services from people because we want to just choose to do random assignments. That's unethical, right? We can't put people into settings where, like the Stanford prison experiment that people might have heard of, that was an experiment, right? But we put people in an ethical and harmful situation, right? So, not to say that anybody is trying to do that type of an experiment anymore, right? But there are ethical considerations, right? I cannot necessarily say, if I want to understand the impact of, spanking on children, I cannot force half of a group of people to spank their children regularly and then force the other half not to, right? There are ethical implications for something like that. We might be able to analyze people that choose to spank their children and those that don't and look at the differences, but that is not a random assignment experimental type of situation. Um, there are some characteristics about the participants we should be concerned about, things like the Hawthorne effect. Someone knowing that they're being studied in an experimental setting might result in them doing something different than they might otherwise do, right? And then sometimes, right, economic, social policy questions, things that matter on a large scale socially, right, are very difficult, if not impractical, to do an experiment, right? What would happen if we chose to cut the defense budget by half to figure out whether or not that's a good policy decision? Is not really a feasible experiment, right? We can't just like have part of the country cut the defense budget in half and see if they are more or less safe than the other half, right? Like it's practically not feasible. So there are things where we are not capable of doing experiments, even if they seem like a good idea. Few different types of experimental settings that are alternatives to the classical experiment. We've talked about double blind studies, this idea where neither the researchers nor the participants know which group they are in. So we do this with drug trials. Somebody on the research team does know who is in which group, right? But we don't want the doctors to know that the person they're treating is or is not receiving medication because that might skew their opinion. We also don't want the patient to know that they do or do not receive a drug because they may report that they feel better because they know they're receiving the drug versus the group that doesn't might want to get treated because they know they're getting a placebo. And so they may treat, they may say they're still sick or worse than they are, right? So that's a scenario where, right, we would make sure that we give both groups a pill that's identical so that they don't know the results and the doctors don't know the person they're treating is on or is not. And so they get an honest evaluation of their symptoms. There's a thing called factorial designs. This is where we might set up multiple tests of different simultaneous manipulations to look for differing or combined effects. For example, I might be interested in doing an experiment on student performance, and so I might have a I might be looking at the difference between lecture versus discussion-based classes and whether or not that impacts student performance. But I also might care about the difference between classroom lighting and dim lighting to see if that influences learning outcomes. And so factorial design, I might have a bright lecture-based class and a dim lecture-based class. And then I might have a bright discussion-based class and a dim discussion-based class, right? Compare and contrast across those multiple groups to see if there's a difference of impact for both characteristics. Web-based experiments, obviously not all experiments happen in a lab. My dissertation didn't require bringing anybody to any physical site to do the experiment. It was all built electronically on a survey using a computer application. People could take it from anywhere. And so we have lots of ability to do these type of things, like a psychologist running an online survey with randomized conditions, looking at like political messaging. The example in the book about watching a video on Muslim culture, right? That can easily be done via a web-based experiment. We also have things called natural experiments. This is where we as a researcher didn't actually plan or initiate the experiment, but something happens in nature, and that might be social, that might be environmental, but something naturally occurs, and we use that change to study causal effects without like our own direct manipulation. So let's say, the city of Long Beach decides to pass, or let's say the county of San Bernardino decides to pass a universal basic income program, but the county of Riverside doesn't implement something like that, right? Those two counties are next to each other. They're similar in a lot of ways, right? We might be able to then evaluate outcomes within a natural experiment of whether things are improving for residents in San Bernardino County compared to Riverside County, even though, right, we as a researcher did not initiate that manipulation. That was a policy decision by one group, right, and set up the conditions for a natural experiment that we can then take advantage of. One of the other things we want to talk about just briefly is deceptions in experiments. So deception is something that can occur. You obviously learned already about research ethics, but deception is one of those things where we may have to intentionally withhold information or mislead participants about the true nature of a study. It is common in psychology, behavioral economics, and other things, specifically because if we tell someone what the purpose of the study is in an honest way, them knowing may actually be problematic for them behaving differently than they otherwise would if we either mislead them or withhold information about what the actual purpose is, right? It is not impossible to have deception in experiments. IRB and institutional review boards can approve deception, but there are considerations, right? If it is necessary because full disclosure would alter someone's natural behavior, you need to be sure of that. You need to be able to explain why you believe that to be the case. Right? You still must not harm or distress the individual beyond sort of an everyday level of experience. And you want to make sure there's no lasting harm as a result of this deception. Right? Being deceived on a grand scale is very different than sort of just withholding some information for the purposes of an experiment. Additionally, participants should always be thoroughly debriefed, right? We always require a human subject's consent when we initiate an experiment, but if that consent is obtained under deceit or deception, right? It is important that at the end of the experiment, we inform that person that they were deceived and why that was, and regain their consent again so that they can consent under sort of true and honest circumstances, right? So they know that they were deceived. They understood why we had to deceive them, and they still agree afterwards that it's okay to use the information from the experiment that they participated in. Now, you always want to make sure you still get approval and ethical review from IRB or something like that. So an example of where we might have to use deceit is, let's say we're looking to do an experiment on decision-making perceptions, right? So we have somebody sit in a waiting room with a bunch of other people. Those other people are all actors except for the one person. And then we have someone who's an actor in the situation that we've created drop their belongings and struggle to pick them up, right? We want to see whether that person that we've put in that situation is willing to help or not. But we need to make sure that the other people in that room that are actors that we've staged choose not to either help that person or ignore it, right? Because we want that to be the conditions, because we want the person in the experiment to decide on their own independently whether or not they would be likely to help that person if no one else does, right? So that person does not know that we are observing them and the rest of it is staged. But if we tell them, hey, by the way, we're going to have you in a study where we want to see if you're going to help this person, right, when they're just struggling, um, like telling them that, they might obviously be inclined to say, like, well, obviously I'm going to help them. That's the point of the study, right? And that would change the behavior to where most people would choose to help if they knew that it was a fake situation, right? And so we're looking to study whether social norms influence that bystander's behavior. We need to set up those circumstances and trick them into a situation that they don't realize that we have set them up for that situation, and then tell them afterwards, here's why we did that, because we wanted to see if you'd help this person. We definitely didn't know. We didn't think we could tell you that that was the purpose, because then we obviously think you would choose to help them 100 out of 100 times, right? So we set up these circumstances and wanted to see what you would do. Are you still okay with us using your information, having known that, right? So there's a lot of reasons why experiments can be beneficial. There's a lot of reasons why experiments can potentially be problematic. In research design, the fact of the matter is no one tool is perfect. There are good things about the classical experimental design. There are certainly ways to relax it and alter it in such a way that it improves the nature of the research that we have done. It can be beneficial. We might have to fit the best research design to the situation that we have. And in some scenarios, experiments might be appropriate and they might be strong research designs and they may work for us. And in some scenarios, they may not. The most common scenario where we cannot use the experimental design is because we don't have the ability to choose random assignment, because it's either unethical or logistically impractical, because people either self-select into government services and programs, or they do not because of eligibility criteria, or because it would be unethical to withhold those. And so what's most common is not being able to pursue an experiment because we have to use non-random assignment and therefore pursue a quasi-experimental design. On average, we can say that that is less ideal, but there are still many, many ways to alter the quasi-experimental design to improve the quality of the research that we are doing, because some evidence towards our hypothesis is always better than just not studying it at all. And so that is what we're going to look at through the rest of this course, is how do we continue to relax and add and modify the structure of these different research designs to build the best or the strongest fitting research design for the situation that we have given the circumstances.